Yeah.
Hi, welcome to another tutorial. This is under bearing. It is WAS November 2015 question 10b, and this is specifically distance bearing. It says a ship leaves port P, so the ship leaves port P and sails on a bearing of 45 degrees north of east. So at this point, you should represent a compass. So it leaves port P and sails on a bearing. So at port P, you should have a compass there. So the compass is the representation of the four cardinal points, which are north, south, east, and west. So you always indicate the north line. Now, this is the north line, this is the east line, this is the south line, and this is the west line. So this is saying 45 degrees north of east, meaning from north measures 45 degrees towards east. And note that from one cardinal point to another cardinal point measures 90 degrees. So if that is the case, then that means the 45 degree should be center of the compass. So we draw this. So this is considered to be the port P, and the ship leaves from this port and travels 45 degrees north of east. This is the representation of that. And then to a port Q, 15 kilometers away. So here is considered to be Q. We can extend this line a little bit. Here is considered to be Q. I mean this point. And the distance from P to Q, according to the question, is 15 kilometers. It continues. It then sails on a bearing of 45 degrees south of east, meaning from south, it travels 45 degrees towards east from the point Q. So it means that the point Q should also be represented with a compass. So this is how a compass is drawn. The four cardinal points always indicate the north line. So this is the north line. Again, it leaves from port Q and travels 45 degrees south of east. So that is from south, it travels 45 degrees towards east. So know that this is the east and this is the south. So we've already told you that from one cardinal point to another cardinal point measures 90 degrees. So it means that the 45 degrees will be halfway between the east and the south. So again. And please note that this time the distance is 20 kilometers away. So that means the line that we are about to draw should be longer than the first line. So take note of that. This is 20 kilometers. So this is 20 kilometers. And don't forget, it travels 45 degrees from south towards east. So please make sure and have the representation of the angle, or else after drawing the diagram, you might forget as to what to do next. Roman number 1 says, represent the information in a diagram. Roman number 2, calculate correct to the nearest whole number. The alpha distance from P to R, meaning P and R should be connected. So the shape left from Q, it went to R. So that means this point is considered to be R. So let's take note of that. We'll position the letters, but it is important that we first have the complete representation of the diagram. Our beta says the bearing of P from R. So please take note, in bearing, the point after the preposition from is always represented by compass, or should be represented by a compass. So it means that at arrow, we should have a compass. If at this point arrow, there should be a compass. So this is N. And then we are told to calculate the bearing of P from R. And we are also told to calculate the distance from P to R. So that means we have to connect P and R. We have to connect P and R with a straight line. The bearing of P from R. Now the bearing of P from R will be the angle measured from the north line in the clockwise direction to the line connecting the center of the compass and the point whose bearing we are finding, which is the point P. So this is the bearing of P from R. The number of turns, this is it. Okay. So as you can see now, we are to find this angle right here. And then note that this line is parallel to this line. And then this is a transversal. So that means if here is 45 degrees, here will as well be 45 degrees. From the angle property that says alternate interior angles are equal. So if here is 45 degrees, here will as well be 45 degrees. So you can clearly see that from this diagram, the bearing of P from R will be the angle measured from the north line to this line connecting R and P. And we've already told you from the beginning that from one cardinal point to another cardinal point, you have 90 degrees. So from here to here is 90. 90 plus is 90. That will give you 180. And then when you reach here, you get 270. So that means the cardinal point east corresponds to 90 degrees. South corresponds to 180 degrees. West corresponds to 270 degrees. And the cardinal point north corresponds to 0 degree and 360, because you start from there, that will be 0, and then you come back there, you get complete revolution, which is 360 degrees. And also know that bearing, prefigure bearings are measured from the north line. The prefigure bearings are measured from the north line in the clockwise direction. So you can clearly see that once we are able to find the angle theta, we will obviously be able to find this number of turns, which will just be 360 minus theta minus 45 degrees. Because when this turn reaches to this north line, you obviously get a complete cycle, which will be 360 degrees. But before then, let's come to, we've already have the representation of the diagram. That is Roman number 1. So Roman number 2 says we should calculate correct to the nearest degree after the distance from P to Q. So this is Roman number 2. Before we can calculate the distance, we have to note, we have to be able to figure out the type of triangle it is. If it is a right angle triangle, then we apply the Pythagoras theorem or the Pythagorean theorem. If it is not a right angle triangle, then we have to apply either the sine law or the cosine law based on the positions of the measures of the sides that we have. So in order to determine that, we have to be able to find one of the angles, one of the interior angles of this triangle. So again, this line is parallel to this line. So this serves as a transversal of this line. If here is 45 degrees, automatically here will also be 45 degrees. So we've been able to find one of the interior angles in that triangle. And we notice that when we add the 45 to this 45, it will give us 90. So that means the whole thing here is 90 degrees. And the only triangle that has 90 degrees, or that has one of its interior angles to be 90 degrees, is a right angle triangle. So with this, we can now apply the Pythagoras theorem. And note that as you apply the Pythagoras theorem, the side that is opposite the right angle, which is the 90 degree, the side that is opposite the 90 degree is always considered to be the hypotenuse. So according to the Pythagoras theorem, so we say from the Pythagoras from the Pythagoras theorem. From the Pythagoras theorem, the square of the hypotenuse, in this case, which is the distance from P to R, which is the length PR, the square of it would be equal to the sum of the squares of the other two legs. The other two legs are the length PQ, and the length QR, So we do not have the length PR, we maintain that, so we have the length PR all square equals the length PQ. The length PQ is 15 kilometers. So we can ignore the unit. We already know that we are working with kilometers, and in the end, length ends in linear unit. So we just have to attach this kilometer. In other words, we just come and write 15 and square it plus QR. QR is 20 kilometers. We see also 20 square. So we'll have here PR, the length PR square. You got a 15 square, that should be 225. 20 square is 400. So let's make use of the calculator to be exact. Plus 400. So PR square will be equal to 625. Take the square root on both sides in order to get the length PR. So the square root of 625 is 25. So this is, remember, they give it to us in kilometers. We say therefore the distance from P to R is 25 kilometers. So we've completed Roman number 2. The next one, we've completed Roman number 2 alpha. So this is Roman number 2 alpha. As I said in my previous video, don't forget to label the solution to the question as it is given in the question. So this is Roman number 2 alpha. Roman number 2 beta asks us to find the bearing of P from R. So we've already identified this number of turns to be the bearing. So all we need to do now is to find theta, and then we can find theta. But to do that, since we know that this is a right angle triangle, we can re-sketch the right angle triangle. It's in an L-shaped form. We know that the right angle is 90 degrees and it is at Q. So that means here should be Q. This is Q. And then we know that PQ is, so we can pull out of P here and pull R here. Or you can pull R here, you pull P here. Anyone can go anywhere. We know theta is where R is. So here is theta. And then the distance QR is 20, so make sure you label it that way, 20 kilometers. And then the distance PQ is 15. So this is PQ, 15 kilometers. So now you can see from triangle, this is a symbol of triangle, from triangle PQR. Now we get a measure of 2 of the sides of this triangle, and then we want to find the angle. So we're going to apply the trigonometry ratio for the basic trigonometry functions, which are sine, cosine, and tangent. So there is this acronym that makes it easy for us. So CAR3. So to use sine, it means that we have to deal with the opposite and the hypotenuse. Cos the adjacent and the hypotenuse turn the opposite and the adjacent. In this case, when we talk about the adjacent and that of the opposite, we reference the angle that is involved. That is the acute angle, which is greater than 0 degree or less than 90 degrees. So this is the acute angle under consideration. So the side that is opposite the acute angle is considered to be the opposite side, and the side that is adjacent it is considered to be the adjacent side. So it means that we get the side opposite and we get the side adjacent. So that means we have to use twice, opposite and adjacent. So we say tan of the angle. The angle is considered in the case of a theta. Is equal to the side that is opposite theta, which is the length PQ, all over the side adjacent A, which is the length QR. So tan theta is equal to the length PQ. PQ is 15 kilometers. Over the length QR. QR is 20 kilometers. So kilometer cannot kilometer. We say 15 divided by 20. So this will give us equal. This will give us 0.75. So you have tan theta equal to 0.75. So you're taking tan inverse on both sides. If you take tan inverse on both sides, it means that you'll be level with theta. There's a trigonometry identity that says, for example, the inverse of a function being multiplied by that same function will give you the argument that is before the function. So in the case, the argument that is before the tan here is the theta. So that's why we'll be left with only this theta. So that's it. So take tan inverse on both sides. You take tan inverse on the side, you'll be left with only theta. Then you also take tan inverse on the right side. This will be 0.75. So you have theta equals. We already have 0.75 in the calculator. What we'll do, we just press shift and then you press tan. It will automatically go there. So theta is equal to 36.88699. It is good. Usually take 4 decimal places when you want to estimate to maintain accuracy. So this is theta value. Then we can now come here and know that the bearing of P from R will be 360 minus theta minus 45. So we say from the diagram, the bearing of P from R equals 360 degrees. As you can see, the whole thing when it reaches to the end, it will be 360 minus this theta, minus this 45, minus the 45 degrees. So this will be 360 minus theta was calculated to be 36.8699 degrees minus 45 degrees. So you have 360 degrees minus. So we say we add these two, can add these two. So we can say 36.8699 plus 45. So this will give us 81.8699 degrees. So we have 360 degrees minus. So subtract this from the 360. And then we'll have, sorry, we already did the subtraction. So when you do that, you'll have 278 degree point 1301. If you want to round up to the nearest degree, you can do that, but you have to indicate it. So you can say approximately 278 degrees. Then you can say therefore, it's to the nearest degree. You can also say therefore the bearing of P from R is 278 degrees to the nearest degree. Okay, thank you very much. We've come to the end of this question. Again, please subscribe, like, and share. Some of your friends who are preparing to sit this upcoming West African Senior School Certificate Examination and feature WASSCE can also make use of this, as this question is related to WASSCE, giving the headline that you see. Thank you very much.